Welcome back to yet another video. Today we are going to discuss about Java Spring Boot Microservices interview questions and answers, which one of my associate attended. Uh, so these are the real interview questions which are going to be shared up, and this is basically, as I mentioned, core Java, Spring Boot, and microservices related interview questions, which he attended in the IT company, and he got the package of 25 lakhs LPA. This is the first round basically, and his experience is around 6.5. Okay, and this is a must watch, I would say, with people who are attending interviews and also getting prepared for their interview, right? This will be one of the uh, most frequently asked interview questions, are also some of the interview questions which are not frequently asked, right? So this give you an insight of what different questions are asked, right? This is company he got selected, and the company name is Capgemini. Okay, so let's begin. So the very first question is about like what is overloading, how it is different from method overriding. Okay, so when it comes to this method overloading and overriding, we think of polymorphism. This is one of the OOPS concepts, and this is the basics of Java. So if you are attending, you should be making yourself aware of like the basics of right OOPS and also the Java, right? So let's look at what is overriding first, then we'll go into the overriding. So we are first looking at the overriding. So basically, if you see, right, the definition wise, or basically what exactly the overriding is, right? So we have a subclass and the superclass, right? So we are going to provide our own implementation in the subclass, okay, which is defined in the superclass. That's how when we term overriding is mentioned, right? So the purpose when we wanted to modify or extend certain behavior of an inherited method, right? So that's what we deal with. So when you want to have your own implementation, right, so in that case we do that. Now this particular method overriding is called dynamic polymorphism, and it is also called runtime polymorphism, because basically at the runtime it is going to decide whether the method is called for subclass or superclass. The signature wise, basically they are quite identical. The names and the parameters are identical, how it is defined in the superclass. Now return type, it must be definitely same of that particular, or it might be the type of covariant type or subtype basically, but it must be same or of same type. Now the access modifier, basically you cannot restrict it. Let's say if you have a superclass, we have some access specifier, you cannot restrict it down to, let's say, narrow it down, right? So you should be taking care of that part. Now when do we use it? Basically it is that, when you want to enhance the behavior of your inherited method. Let's say you have written certain implementation, now you wanted a better version of it, right, or a better way to handle it. That's where we take this particular approach of overriding it and then having our own implementation. So this is an example. Let's say you have an animal where you have some sound, right? So now you want to, let's say, animal, like there are different kinds of animal. Now you want to have a sound of the dog, right? So let's say you will implement your own behavior or own implementation, like how the dog would sound out, right? So it cannot be a general sound, right? That's how you're writing your own implementation over there. I hope you got that particular overriding concept. Now let's move on to the method overloading. Now this is one of the another part of the polymorphism. So definition wise, or like, what exactly it means is that there will be exactly same method name, but there may be a different parameter names. Okay, so that number of parameters, the type of the parameters, or in either case there can be both, right? Number and the type, this may be different. Okay, now when do we use it? Purpose is actually is that when you want to perform certain similar kind of operation, but that it might take some different inputs. Okay, so that might be the possibility. Polymorphism, now as method overriding was at runtime, now overloading, it's about compile time. You will be able to decide or get the understanding that it is compile time polymorphism, and like it is called static as well, polymorphism. Now the signature wise we already discussed, it might be different, the number of types of the parameters. Okay, the method name is same. We already discussed this different, but it is not going to overload, right? So that's what access modified. Yeah, definitely we can vary. We have different variations in that. Now when you want to have certain methods, or let's say you wanted to let's say create some PDF, right? Example. Now create method, create PDF, like it can be taken up just simply you can create it. You can add some inputs. You want, let's say, XML access. The input is like XML, or any other input source, right? So that might vary. That now the parameter may vary, right? So but the it might be, the method name will be same, but the parameter or the input will be different. This how the implementation. Let's say you have a calculator, and then you have certain addition, right? So which is going to take two parameters. Now there can be an addition which is going to take three parameters, or let's say there is an addition again, but it may take some different parameters, which is, let's say, different of variable type. Now, how do you demonstrate the difference between the shallow copy and the deep copy? And that has to be explained using the Java clone. Now, this question is not generally seen in the interview, right? So, but basically, these are something which definitely comes up if you are an experienced guy. Uh, Now, what is shallow copy? Now, basically, when the very first thing about like shallow copy is that you are going to create a new object only, but it is not going to create an object which is contained in the original object. So I mean, basically, instead of, it is going to copy the reference to the original object, right? So that's how the difference is. Like as a result, like the changes made to that particular object in the shallow copy will also affect the original one. Okay, so since original and the copied one objects are going to refer to the same object in our object, so they are pointing to the same thing. So that's how what shallow copy is about, right? So it is referring to the same original object. Now, what is deep copy? Basically, deep copy is nothing but it is again going to create a new object, but basically in this, it is going to copy all those particular content from that particular object, and it is which is there in the original object, is going to create a new one. Now, this means original object will be intact. It will be completely independent of this particular new object which is created. So whatever the changes you make to the inner object or the one which you have copied it will not affect the original object which we have referred from. Okay, that's how deep copy is about. Now, as we spoke about what exactly the clone, right, method will comes in picture. Now, clone is basically used when you wanted to get a duplicate copy. Let's say there is a complex way of creating, and there are multiple steps to create that particular object, and you doesn't wanted to go again creating those particular steps. You simply want a replica or a copy of it. You use the clone, right? So you are going to create that particular object. So by default, clone is going to perform a shallow copy. So that's it. So that means that your original object will be impacted, but you can have your own implementation by overriding it, and you can have a deep copy implementation which you can explicitly create, and there will be a different internal objects created for it. Okay. So let's look at the first copy, that is the shallow copy. So using the example of clone, now we see here there is a person class which is going to contain the car, right? Now we are going to perform under that. If you look at the particular clone method, okay. Now it is throwing an class not, sorry, clone not supported exception. So basically, if you are not able to clone it, then the exception will be thrown. But if you see here, that is simply going to clone it, okay, then it is going to return that particular clone object. So basically, whatever it is there in the original object, it is going to do that. Now, if you see here in the main method, okay, so we created a Toyota, and then we have an Honda, right? So basically, if you see, the original name was Toyota, right? And then if you see, we are printing this particular person one object and the person two objects. But if you, but for your surprise, if you see, the both the names are changed, right? The original object name was Toyota, but definitely if you see, you have made the changes and you have reassigned it the value to the Honda, it definitely changed. That's what denotes the shallow. Now, when we think of deep copy, like using this clone method, again you have to look at the particular clone method. But here if you see, there is a cloner called up, and then if you see uh, from the super, but if you see here, we are deep cloning it, right? So we are calling that particular class method, then we are deep cloning it, right? So that's how we differentiate it. Now if you see here, so if you see here, if you the original name is like, Toyota, and then if you see the car one, now if you are going to print that, right, it is going to print different name, right? So in this case, what has happened is that the person, uh, when we override the particular clone in the person class and the addition to the person object, right, we explicitly clone the car object. Okay, so that's what, we have cloned it and explicitly modified the car object. But if you see the class object of that particular person 2, it has remained unchanged. Okay, that's how the difference of, it's an independent object, right? That's how they are changed. That's what the deep copy is about. Okay, so the next question is about how would you implement a string interning mechanism without using a Java string intern, right? So basically, if you have heard of this particular intern term, it's an mechanism where you are trying to use and have a better memory efficient and reuse of that particular object. So it's a way of, creating objects in efficient in the memory management, right? So that's where we use the filter. Now string, basically, if you, it involves certain, storing that particular one copy of distinct value in certain one of the memory, that is, in order to improve the memory usage. And especially when you are dealing with string, right, so it is usually, some, in many cases it is repeated. So string intern, if you see, it will help you, helps this, but we can implement our own version to handle this particular string internal manually. Now how do we do that is that, first we have to do that, we have to implement the string intern, right? So what we do is that we have to maintain a central repository, so whether we can use hash map or hash set to store certain intern strings. Okay, now we have to ensure that each string is only one instance exists in the memory, that is no duplicates. Okay, now when the new string is requested for interning, right, you have to check already if it is existing in that particular repository or not. If it does not, then you have to, if it does exist, then you have to return the existing string reference, or else it is going to create and add it, and then, it is going to return the string new string reference. That's how we can implement it. Now if you see this implementation here, in the intern method, if you see, it is going to check in the string pool. Now string pool is nothing but an hash map over here, if you see here. So it is already, it checks for the contains key over there, right? So if it is there, then it is going to return, or else it is going to put that element and then it is going to return it. That's how it is going to return. So this is how we can implement the string intern mechanism, apart from like how the string then is already implemented. Okay, uh, this is all what, we have already explained about it, right? Now there is a question which is normally, it has appeared in many questions, but this is an, most frequently asked, I would say, and in some cases actually people tend to doesn't ask this because this is something quite basic. But yeah, what is the difference between this and the superclass? But this makes the interview understand that, you have your ground strong, and then you have very strong hold on Java, right? So that's what indicates it. Now when you compare this particular things in terms of referring, right, so this is going to refer to the this basically it is going to refer to the very current object, that the instance object, basically, right? But when you are referring to the super, right, that is it is going to refer to your parent. That's what the super method means, right? So super is something, but when we are going to refer to our original parent. Now, where do we use it? Basically, we use it for accessing the instance variable, the methods of the current object. You need to call, let's say, another constructor in the same class itself. So there are multiple constructions which have different parameters. But in case of super, right, so what you do is that you access this particular method. You have this particular variable method of the super class if you want to attend it, call it. That's what we use. And basically, if you want to call any super class constructor also, we use this. Now in terms of constructor, now this is used in to call another constructor as we already discussed. But in super we have already calling the super using the super constructor, right? Uh, let's say you want to access the parent members, right? So you cannot access using this the parent members directly. Now what you can do is that with the super it is easily accessing the parent fields and the methods. Now when it comes to overriding, it does not uh, deals with parent and child relationship. It is going to deal with the same things, right? So it will not have the involvement of method overriding. But yeah, in superclass we are dealing with method overriding, and then we have a superclass subclass relationship over here. That's what the difference is about. Now, in terms of Java 8, you must have heard of popular framework that is Stream API, and you wanted to understand what is the how Stream works in the Java 8, right? That's an example. He wanted to understand like what is this filtering, mapping, and reduce operation does, and on the collections, right? So, I wanted to understand how it internally works. Now, basically, what exactly is Stream API is an clear and the powerful and the concise way to handle the collections of data in the functional programming style. So that's way how you want to deal with the collection, right? So that's how we make use of string API. Now there are different operations like filtering, mapping, reducing on the collection. So which is quite easy and it is quite maintainable and readable. Okay, that's what the benefit of using it. Now how does it internally it works is that basically it streams are nothing but it is going to represent the sequence of elements that they're going to have some support of aggregate functions or operations, right? Now these operations can be declarative manner, they allow for a better readability, and it supports the functional style of programming. So stream is not a actual code data structure, but you would say it is a sequence of elements from the source. The source can be anything like collection, the set, or the list. Okay, and those can be taken up and processed in either parallel way or in a sequential way. So that's how you act on or work on the collections of not you're not dealing with the exact collection, you are dealing with a copy of it, right? So there are intermediate operations like stream is going to perform another. So when you're dealing with intermediate operation, let's say filter or something, it is going to produce another stream. Okay, so these are called lazy operations. Basically they are not going to be executed. Let's say you're calling filter, now until you doesn't call the for each or the collect, it is not going to execute that. Okay, so that is this execute for each and these are called as a terminal operation. So basically these are going to be triggered right when you are after the stream, and then you perform the middle layer of intermediate operations, and then ultimately wanted to produce something as an outward as a result, right? So that's where we make use of the terminal operators. Now, as we already discussed, like there are different filters, map, and reduce methods. So these are used on different purposes. Now let's look at the examples. So if you see here, we have a person class, and then we have different. Let's say we have taken all these particular three filtering, mapping, and reducing in some one single example. Now, very first thing, if you see, I'm going to filter out those particular persons which are age greater than 30, right? And then I'm going to ultimately collect that into a list. That's how I made use of filter, and then I'm collected into the list. Secondly, I'm going to make use of the mapping. Now, basically, I'm going to convert the list of people to their list of their names basically. Okay, so I wanted to take out that individual extraction of the particular name itself from the list. Okay, so what I have to do is that I have to map that particular from the stream. I'm going to map it and I'm going to get that particular get the name, and then ultimately I'm going to convert it into a list. Okay, now reducing. Now what I want to do is that I wanted to combine all the comma separated or something over here, right, into a single thing. So that's how we I mean, if you see the reduce method, we are going to combine that particular name with a comma separated. That's how we make use of it and reduce it, right? So that's where we uh, convert the multiple elements into a single, or we will reduce it to single thing. Okay. Uh, so if you see here in the reduced, it is called comma separated in a one single thing. Now, the next thing is that how do you implement a thread safe map? Now, in terms of thread safe, like you must be having an understanding of multi-threading, right? So this question is about multi-threading. How do you implement the thread safe of map? So specifically about the map, right? So where when you're dealing with multiple threads, so that map can be concurrently accessed without causing any havoc or race conditions or data inconsistency or deadlock. Okay, so there are different ways to implement threads here. We'll look out it. There are like synchronizing collections. We have concurrent hash map. We can have our own custom implementation. Okay, so if you look at it, the first thing actually what we talked about is concurrent hash map. So that is one of the recommended way because it has got concurrency API benefit. Now it is part of the Java util package, and mostly it is quite efficient when we are using or when we are implementing the thread safe map. Okay, so it will allow that particular concurrent accesses to that particular map in a multiple threads. So it is going to maintain that particular performance of that particular thread map, right? So that's how it will give a benefit. Now, if you go underneath the concurrent hash map, it is divided into multiple segments, right? Like buckets, and those each buckets have got their own way of performing operation, and it can acquire lock, right? So there are multiple threads which can operate on different sections or part of the map, and then we can concurrently operate on it. Okay, so that's how there is a more fine-grained way of locking it. Okay, and it will not block all the threads, and where you have one thread which is trying to access that map, right? So that's how you deal with the thread safe things. Okay, uh, now this is an implementation what we just took look about, like there is a concurrent hash map implementation. Then we have this particular runnable task. We put that particular inside that particular element. Here if you see, we have an implementation of thread, and then we're going to start it and join it. So that's how we make use of it. Okay, so the advantage is that we have a high concurrency, so multiple threads can ride it, right? Secondly, it is going to be thread safety. Second, it is much efficient when you are dealing with performance, or you wanted to have multi-threading environment when you're comparing with dealing with the lock mechanism of map, right? The second way is the collection dot synchronize map. There is another way, and it is used to be prior to concurrent API, concurrent hash map being introduced. Okay, so this is called collections dot synchronize map, which is going to synchronize your map entirely, and there is it will only one thread can access that particular method. So that's where we can make use of it, right? So to convert that particular map from a simple map to synchronized map. Okay, that's how we make use of it. Now, the disadvantages about this is that it is going to block your application. Let's say it is synchronizing. Now, what exactly it is trying to synchronize, it means that it is going to degrade your performance because it is trying to access or acquire a lock on the particular whole map. It is not going to release the lock, right, until it is done with the operation. That's how it is going to acquire that lock and then perform the operation, and then it is going to leave that. That's the disadvantage. Now third is like you have your own thread safe map implementation, but that's what you want to, if you want to have more fine grained control of the lock-in mechanism, then we have lock, like we have this lock, re-entrant lock, like we have our own implementation. So that's where we can make use of it. Okay, so that's the way we're going to make it. Now, what is iterator interface and how do you traverse in the collection? So basically, if you are aware, like iterator is nothing but you are going to traverse on certain collections and elements. Basically, that's how we use it. Now, if you wanted to do that, there are an has next method. There is an next method. There is a remove method which you can traverse, and then also you have a provision to modify that collection. Okay, that's how we make use of the iterator. Okay, You have to declare an iterator, then we have to list iterator it, then you have to navigate those particular item by item using the hash next method. That's how we deal with it. Now, what is priority queue? It is nothing but a queue where your elements, which are stored according to the natural order of, or basically, if you have an implementation of comparators, then it is stored according to that. But it is used to prioritize or certain elements over the other. So there is a sorting or ordering proper things which it is used for. Okay, that's how priority key is about. Let's look at the next question. Now, how would you compare two strings in Java? Now, this is one of the important questions when it comes to using the double equal to operator. So, when you're comparing two strings, how do you compare it, and like how it is different when it comes to double equal to? Now, when you deal with equals method, right, it actually checks out the two strings, right? So, when s1 dot equals s2, then this is going to be true because the content is going to be the same. But when it comes to double equal to operator, it is going to compare the reference, not the equal the content inside it. Okay, so the memory location where exactly it is stored up, if they are pointing to the same thing, it is going to be same, or else it's going to be different. So that's how we have to answer it. Now, these are generally the questions which they expect is that what are the new features introduced in Java 17. Now, majorly, like the interview focus is about on Java 8 and their features. But as the Java version is going on, there are new features like release is going on 17, 21. Now there is a new version being coming up, right? So as and when these are going up, they expect you to be upgraded with those particular uh, releases of versions, okay, and be updated. So it will give them that you are keeping yourself updated and updating your knowledge. Now, if you look at the very first or the important, I would say this is the seal class feature which was introduced, and it will restrict the classes or the interfaces which can implement them. Okay, so there is a restriction where not everybody would implement it or extend it. There will be some restriction imposed here. There is a strong encapsulation of JDK internals, which there are some internal APIs which are restricted, which was introduced. There are some new Mac OS related pipeline being used in the Apple Metal API, right? So that's what the features introduced in Java 17. This was not very much major, but majorly if you check it out, there's a sealed class related thing which has been introduced and is quite important. So when we talk about the sealed classes, right, it is nothing but uh, uh, it's when you have a classes or an interface which is going to restrict other classes which is going to implement or extend it, right? So earlier it was not a way where we used to restrict it, right? So this was I mean the subclasses were allowed or implementing the classes explicitly. So that's what we used to do, but now we have a precise control, and only the limited set of subclasses will be able to extend it. So it is going to be easy managing those particular things, and hierarchy can be easily maintained. So what is the characteristic over here? So one is that there is an restriction on the inheritance. So the only classes that are explicitly mentioned in that particular permit clause, only those can extend and implement it. Second, explicitly subclassing, you must declare that particular class in the extend seal class, so that will permit. Okay. Now final non-seal class or seal classes, subclasses can themselves be sealed up, but like final they will not allow any further subclassing or non sealed, right? This can be used up, I would say. Now, what is the way to declare a sealed class? Now if you see, you have a class, I mean, then you have a public and sealed classes, and then the name of that, and then the permit, the one who is going to permit that circle and rectangle. Now that's how we use that. Now, the first thing is if you notice that there is a sealed keyword. Second, there is a permit one, which has to be, which will disclose like, which all these particular classes can extend or, these things. Now, by having these particular sealed classes, what is the benefit, right? So now we have more control over the inheritance. You have security that, none, there is no, unpredicted things, or, you cannot risk somebody is going to misuse it, or, some errors are going to throw up. There's a better, I would say matching, pattern matching over here. So it will quite easy for matching it up, and then, it compiles. So it knows all the possible subclasses which are, going to extend the C classes. Okay, it is going to be efficient and exhaustive, right? So there's an improved better design here, so we can help creating a domains, models, and you can limit certain hierarchy which you doesn't want that to in very intendedly. So this is how we can actually create it. So if you see at the rectangle, we have created a shape, and then we have that particular circle and the rectangle. Then we have circle, and then the implementation of it, right? So it is allowed to do that. Okay, that's how we can make use of it. Okay, I think yeah. What is lambda expression? Now this is quite important feature of Java 8. And lot of things, a lot of time it is been asked up. So this nothing but like it's one of the fundamental features which is going to change how we deal with the functional programming, and it is going to enhance your language expressiveness. You are dealing. I mean, it will be pretty concise and flexible, right? So it is going to define some anonymous functions. It will not have any name. Okay, and you can pass the arguments over there. Typically, it is going to be a definition of behavior of a method. So particularly when you are working with a functional interfaces, right? This is what the main when you are going to use the lambda expression. Now, if you look at this particular syntax, right, we have parameter expression. Now, parameter can be zero or then more than one, then the expression will have that particular body part, right? This is how if you see A, B, and then we have addition over here. So that's what the lambda will take care of it. Now, if you look at this particular benefit of using the lambda expression, one is concise and readable. So the developer is going to be writing a clear and compact readable code, especially when he's working with collections or event, right? So this will reduce the verbosity of the code, especially when you're dealing with anonymous classes, right? So that will give a benefit here. So here I have given example of like when you're dealing with a non-lambda way of dealing with an collection sorting, right? This is how you have to deal. But when you are dealing with a lambda expression, then if you see it's how the 4 to 5 lines of code is being reduced to simple one line, right? We reduced it. So that's what the advantage is about. Secondly, if you see, it is going to enable the functional interface concept. Now, this is something where you deal with the existing functional interfaces like runnable, comparable, and also they have central new functional interface been introduced. So we are going to simply make use of it, right? So that's what we'll make use of the functional interfaces. Thirdly, we are going to improve the collection processing using with the help of Stream API. So let's say you're performing some filtering, mapping, reducing, sorting, right? This will give you a benefit of achieving that in the functional style, like the operations on the collections, right? So that's where lambda expression is extensively used along in the with the Stream API. uh, Improve parallelism. So what happens is that when you are combining the lambda expression and along the stream API, you are going to have a better and efficient way of processing the data in a parallel. So you can easily convert your sequential stream to a parallel stream, and which will definitely improve your performance because you are going to take the benefit of multi-core processors, right, in your system. So that's how we can take advantage, right? So which will improve definitely the performance. Now, clear event handling. So basically, when you're dealing with lambda expression, which is going to handle the make the event handler more concise and readable, right? So when you're working with, let's say, listeners in the UI, like swing or Java FX. So that's where uh, I mean, we'll make use of it. Uh, the last thing is that we will make use of the functional programming concept. So that's what matters, I would say. It supports method references. Now, when you're dealing with method references, like there's another feature of Java 8 which will allow you to shorten that particular thing and refer to its method name. So that's what you doesn't have to call it with the see, the method will be called with the method reference itself. So that's what the benefit is about. The last one is we are going to facilitate the reusability and the composition factor of it. So it is going to allow you to compose certain behavior in a modular and the reusable way, right? So instead of defining very large classes and defining the behavior, you can define some smaller reusable behavior and then you can combine it together. So that will be a added advantage. Now, Stream API, how did you, now many interviews ask is this like, how you improve the performance, right, of the, like using the Stream API. So, and how you will improve the code readability. Now, I mean, we already know like it's a functional approach of, processing the sequence and elements, but it is also a very, I mean, when we call that particular streams are lazy, right? So it means that it is going to only process whenever it is going to need, right? So it will save a lot of, it is going to improve your performance. Okay. So in this example, if you see until you're calling filter over here, but until you're calling for each, that filter will not be called up and there will be no processing happening. That's the performance improvement. Now, what is difference between Spring Boot application and what is at the rate auto enable configuration? Now, this is an in general question and it's quite basic questions which normally you see in the interview. Now, these both are like annotations which are quite different and used in conjunction, or I would say one annotation is part of it. But yeah, we'll look into the very first thing is at the Spring Boot application. Now, this is an combination of three annotations, basically at the rate configuration, at the rate enable configuration, and at the rate component scan. So basically, you define this one annotation, it will take care of all this particular thing. But let's say if you are dealing with the enable, let's say you're looking at the explicitly the at the rate enable auto configuration. Now this is an annotation which tells that Spring Boot is going to automatically configure your application certain based on the dependencies available in your class file. Now this means it is going to automatically configure your beans, and the libraries that are included in the project, such as database configuration, web configuration, etc. Now it will scan your class path, it will detect your libraries. Like let's say you have some Tomcat libraries, automatically it will configure your relevant beans and classes which are required to run that, right? So that's how we can make use of this auto configuration, I would say. Okay. Uh, when you explicitly look at the functionality wise, this is the combination, as I said, combination of all these three. But when it comes to explicitly at the rate enable, it is going to be responsible for auto configuration space, especially. Now, purpose basically, they are used for kickstarting your application, the Spring Boot application. But enable auto, it is used for auto configuration of an application. So it's quite custom configuration you can define, right? You can it will enable your auto mechanism, right? uh, at the high level, the scope things actually it is going to include your auto configuration features and on your main class. But yeah, if you go with auto enable auto configuration, it is going to be primarily focused on enabling auto configuration, which is used for configuration classes. Now, when you are using or when you're using the annotations, right? It is common it is a starting point, right, at the Spring Boot application. But at the enable, it might not be the starting point, or maybe it's a custom class where you define it, right? So you doesn't want to let's say you are not using the Spring Boot application, right? You can use this and you can actually apply your auto configuration selectively, right? So the next thing is like what
how you can actually make use of the multiple profiles, right? When it comes to Spring Boot, right? So, and how do you switch between them? Now, this is one of the first way. So you define your properties, that is Spring Profile active, that is any environment like dev, prod, or staging. You define it here. This is one way. Second is there is a command line way where you can, when you are running your application, you define your jar and then you define the profile here, right? You see here there is an active profile dev here. Now after that you will be going to build that ambient rule, and then you can run that using the profile as well. So that's how we define that, right? That's a command line way of executing. So one is using the normal Java jar file, one is using the Spring MVM feature. Now, however, apart from above the two, we have the third way, that is programmatic. We have the particular application, Spring Boot application. We define that particular my class over here, and we're going to suddenly define your additional profiles over here. Then you run it, right? That's how we deal with it. Apart from that, you have the environment variable, which is Spring Profile Active. So this is going to be an environment variable where you can export it in the this thing. So that's how we can make use of it. Now, how do you? I mean, you must have heard of this particular aggregate component, service, and the repository. Right? These are all, I would say, a stereotype or the specialized versions of aggregate component, and they basically used to define in different contexts. So we'll look into it. Now, if you see at the very first component is basically used in general purpose. So if you see, it will be at the top of the hierarchy. Under that, there will be a three annotation, which is going to be an kind of an implementation part of it, and it's going to take the essence from the apparent component. Secondly, that is an at the rate service, which is this is we can make use this interchangeably, but it may not be a better way to write it, because each have their own purpose. Like service is doing their own part of service layer. You cannot swap it with the repository layer, right? So it will, the meaning will change. So it is going to indicate that it's a service layer. Repository, it is going to indicate that it's a data access layer beings, and then you will provide some additional translation over there. Uh, Now, this is how do you externalize your Spring Boot configuration, right? So this is quite important question, I would say, and you should be well prepared on it. Now, if you see, externalization is very quite important when you are dealing with the configuration, right? Your production environment related thing you can define over there, so that it doesn't hard code it. When your application is deploying, the same application is getting deployed on different environment, you doesn't need to hard code anything inside. So it will be pretty maintainable, and you have a different configuration for different environments. That's what the benefit is of it. Now, how do you do that? The first way is that you have the properties files. You define those. You that is according to your location, right? You can place that. Now, as I mentioned, like we have command line arguments, or you can define those that is config location property to that external thing, right? You give that particular under the Java that jar file, and then in that particular location you can give that particular part to that particular property file, right? Uh, After that, you have environment variable. Now there is one environment variable which is Spring configuration config location. You can specify the external configuration, like directory or the file. So when you need to export, write that export, and then you make it use it over there, right? You along the chat, right? That's how you use it. Now, when you're dealing with the second approach, that is the properties, or you can define your own custom location, right? You can define it using the property files. That's how you make use of it. Now, there is a third way, that is profile specific. Now, if you see here inside this, you have the explicit location which we have already discussed about, but in case of production, you can define it in the file loaded. Third, I would say fourth, right? There is an address value where you can define those external properties. So we can directly inject from the external files or the directory over here, so right? In the Spring brings into the values, right? So this is how we define it. Now, let's say you have app name, you define it over there. But if you go to that particular in a class level, you have at the rate value, you map it with that key, right? And then you have the particular value. And then after that, you can make use of it, right? And you can do the location of that config, right? That's how we will get that values from. Uh, One is using the Spring Boot config data, that is API configuration. So that's one of the newly introduced, or I would say 2.4, right? We can configure that, right, in the property loading mechanism. So uh, that's how we can make use of it. This is using the cloud config advanced. Now if you are working on a distributed application, right, centralized configuration, we can make use of the Spring Cloud config, which is used in the microservices environment, where you give the URL of this particular information in the property files, and your config server will be configured automatically. It will fetch this particular configuration from there, which is the active profile and other properties. Uh, Externalization, yeah, I mean, we can actually, using the environment variable also, we can use it. So we'll define all this particular export over here, and then we can inject into the application, right? So that's how we make use of it.
Configure Spring Boot for asynchronous execution of our methods. Now we have an annotation that is at the rate enable async to which you can enable your asynchronous processing, and at the rate async that can be applied on the method that should be run asynchronously. So the task or the logic which has to be written is written in the method, and then you have to apply that async on the method. So if you see here, there is an example where we have a configuration. With the configuration, we have that at the rate enable async, and then we have a method which is defined as an async method, which is going to with annotated with at the rate async. So that's the code where you have to write your asynchronous logic. Now, what is the difference between at the rate entity and the embeddable? Now, this is the term used in JPA. So when you're dealing with any database using the Spring Data JPA, okay, we make use of it. So that's the uh, one way. So that's the difference. So here, if you see here, uh, at the rate entity, basically it is used for the table indication that that is for the table. Now at the rate embeddable, it is basically used in, it's a type of a value type, so that can be embedded in an entity. So it is at the root level it is entity, and then under that there will be an embeddable, okay, annotation which will be used for an entity which is an embedded. So let's say if I have an employee, then he is going to have an address entity or department entity, something like that, where we can make use of this added and embeddable. Now, when you're dealing with Spring Data JPA, there is always a need of pagination and sorting, because there are millions of records. There are some data which you need to efficiently pull the data from the database without putting load on the database. So pagination and sorting is one way where you can apply this. Okay, so this is one of the important features which is going to set I mean, where you can access the large set of data very efficiently, and you can split them into a smaller chunk, right? And you can also order them. So that's it has got inbuilt library or a support, I would say. There is, like, we have interfaces pageable and sort. Okay, so that's where we use. So first we'll look into the pagination. This is going to allow you to display the data in a paginated form. So if you have seen, there will be kind of a table where you will have some sort of click button where you will be able to click on that, and then data will be fetched from the database. So there will be a predefined uh, I would say configurations, okay, which will give you the number of rows or the data which needs to be pulled out. Okay, so that's where we make use of it. Okay, now if you see here, as we have extended that particular interface, that JPA interface, JPA repository, okay, and under that we have written a find by department. Now if you see here, there is an pageable which we are going to pass it as an interface, right? So it is going to pass that, it is going to be retrieved as an paginated result. Okay, so this is how the full code would look like. Okay, So under this, if you see, there is an pagination and say sorting is happening at once. So there is a page under the pageable, you'll see the page request which will take off, and then under that you'll have a page and the size and then the sort one. So all things is applied in that. So this is the way how we make use of this pagination and sorting. And if he asks about like how do you implement that, right, you can showcase this particular code base. Now in the controller, let's say we have handled this particular thing, right? So there will be a method which is going to call the service layer, right? So that's how we implement it. Now second is sorting. We already checked it in the code, but as we already mentioned, there is an second attribute, that is sort by, where we can actually sort it with the help of descending or ascending. We can name that over there. Now third thing is that we can handle the uh, I mean, we can individually handle the pagination separately and individually handle the sorting separately, but you can also handle that and handle it completely at the same time, right? So that's how we make use of it. Okay. So if you see here, we have a list of employees. Then we have two things over here. One is in the from the get employee. If you see here, what we are doing is that first we are sorting it with the help of these particular directions. Second, we are passing that particular direction inside that sort, and then the third thing is we are passing the page and the size inside it. Okay, so it is going to sort it with the field by the name and the salary. That's how it is going to take it, and then in the direction of ascending or descending, which you can do. Now there is a concept called eager loading and lazy loading. So it is basically how your beans or the entities are loaded from the database at the start of the application. So when you are loading your application, right, so you can use the relationship along with the fetch types, whether you have to load it eager or whether you have to load it as lazy. So now when you're using lazy and when you're using eager, there is a lot of difference when it comes to the entities which are there underneath, right? So if, let's say if we have employee and under that there is a department, right, and under the department also there might be something else, but let's say employee and then the addresses, right? So the user can have n number of addresses, right? So that it will at the load of the application, it will not going to, if you keep it as lazy, so it is not going to load the addresses, okay, until you access it. Now when you keep it as an eager, you is going to load the employee as well as the addresses also if you have an annotations defined for it as an eager for the sub things, then it will load as it is, right? So that's how the lazy and the eager works in. Okay, so that's the it has got a benefits and also the disadvantages when it comes to loading the large set of data, okay, and the relationship. So how complex it is, like one to many, many to one, or many to many, that depends on that particular relationship. Now what is the use of at the rate modifying annotation? So basically this is used along with the query, right? So when you wanted to update certain update or delete, right, then you need this particular uh, at the rate transactional for modifying this particular query. So you can use this and you can annotate it with the just above the at the rate query. Okay, so that's how we annotate it. Now if you see at the example, first we have defined the at the rate modifying, then at the rate query, and then we have the actual method over there. This is how we make use of it. Now when you are dealing with transaction, there are two things. One is isolation and the propagation level. So at the top level there is a transactional, and then at the underneath there will be an isolation levels and the propagation levels. Okay, so it depends on your what is your need or what kind of management the transaction you want to happen, right? So there are some, the highest level of serial, if you want to prevent dirty reads, non-readable, phantom reads, then then it's completely, you want to ensure that you use this serializable, but it has got its own performance degradation, right? So although your data will be of highest level, but there will be an full isolation, and then there will be a quite performance impact, right? So there are some propagation behavior as well, right? So it will denote like how your method is to be called with your existing transactions, right? So there are propagation required, new, nested, supports, not supported, mandatory, never, unknown, right? So each of this plays a very important role when it comes to your need and how you want your request to be handled, right? And the transaction to be maintained. Now, how do you configure Spring Boot for microservice to register Eureka? Now, this is the questions which are asked in terms of microservices. So, when it comes to Eureka or a service discovery, so there is a Spring Cloud Netflix Eureka, which is called, right. So this is a dependency which you have to add it in, then and then your application.property on the YML. You will have to define your client registration details where your this particular server is enabled, right? That's how you define, and this is the information. Now, how would you handle the security in microservices based Spring Boot application? Now, basically, there are multiple ways, but will depends on the kind of what mechanism are you using. So, if you are handling security, right? So you have to ensure that your data is protected, your secure communication is secure, right? That's how when you're dealing with microservice based architecture, right, you have service to service communication happening. Okay, so in the broader term or the high level, you have this authentication and the authorization, where we can make use of this OAuth2 framework, and then JWT as a web token. So we can use JWT for the stateless authentication process between the microservices, and we can use AO2 to manage the authentication with identity provider like ClickLock is there, OAuth2 is there for securing your API basically. Okay, so that is used for that. Now you can integrate your endpoints, and you can handle the authentication and authorization, okay, with above steps. Now, when you're dealing with any microservices, so there is an API gateway, which you can either use Spring Cloud Gateway, Zool, or any other provider, or you say, which is going to centralize your security. It will manage your authentication. It will route your request to certain services, which is going to be very secure. So basically, a microservices, right, at the backend. So it will first authenticate. The API gateway can authenticate your all your requests which is coming to that, either via JWT or either via OAuth2. So then it will, once it is satisfied and logged in, then only it will go into forward it to the second, the desired services. Then there comes to a service to service communication authentication. Now there is an TLS, or MTLS, that is, or you can use OAuth2 client credential flow, which you would use to authenticate services when they are communicating with each other, right? So for when you're dealing with microservices, you have to ensure your communication channel is HTTPS, right? So to make it secure communication. Now there are role-based access control. So you can implement certain role-based controls to ensure that user or a services can only access certain resources if they are entitled to, if they are authorized to use it. Then this can be managed something in the Spring security roles along with the JWT claims we can define in the services, right? The permissions basically. Now there is a centralized authentication services. You can use of this, like there is a key clock, Okta, which you can handle your user authentication for all your services or microservices. Then comes securing your API. So you have to ensure that you are restricting certain sensitive endpoints which are not entitled for any all the broader audience, right? So you can use that security annotations like pre-authorized, secured, which can implement, right? So and then also you can implement the rate limiting there, where, and also API throttling, which can also mitigate certain risk like DOS attacks, right? So which will prevent that to happen. Now you can have logging and other auditing also. So there are logging and auditing which will track and your accesses whatever it is there, and then it will monitor your the suspicious activity which is coming from the services, coming to the services, right? You can use ELK stack, you can use Splunk for centralized logging and monitoring, right? You can combine either like AOAuth, OAuth to, you can use JWT, Spring Security, API Gateway, and some role-based authentication control. Then you can build your microservices which can be scalable with the help of Spring Boot. I hope you got this. Now, what is Swagger? Basically, this is not an in general generally asked, but I would say when it comes to microservices interview questions, right, you will definitely see this. But Swagger is nothing but a documentation, a framework which is used for documenting and testing the REST API. So it will provide you certain set of tools which will automatically generate the API documentation, make it easier for the developer to understand and interact the APIs, what exactly it is, right? So first is when the documentation, it gives you a clear cut, automatic, generative, interactive, and user friendly documentation for any API you design for it, right? Then you can test it. So you can also test the by trying the endpoints directly on that particular documentation interface, that is called Swagger UI. Now after like certain version, it has been named as a different, but yeah, this is what actually the previous version it used to be, and now it has been named a certain different name. But yeah, so API standardization. So basically, if you latest one, it is called as an open API specification, which is got three. So which has certain standard or format for describing the RESTful API basically. Now you can also generate certain codes like SDK and server stubs for various programming language for this particular API specification, right? So you can use that. Now, there is an web-based interface where you can test it. Okay, and then if you see here, we have I mean, when it comes to Swagger as a term, right? We have the UI, we have an editor, and then we have a code generator. So which is going to generate the certain client libraries and stuffs. We have editor where we can actually tools for designing your APIs like with the which has to be according to the open specification. Which you can make use of it, and then we have a user interface where we can make use of it to test your application. Now, what is CloudStream in microservices? Now, if you haven't heard of this, or in general, if you have not come across it, this is a messaging framework that is built on top of the Spring Boot, and then it is got into Spring integration. So, it is going for the what it benefit is that is going to simplify your development for your event-driven microservices by providing certain consistent programming model. Now it has got various integrations where we can do with Kafka, RabbitMQ, and others. So these are the configuration which you have to mention, like the input and the output destinations. Okay, and give the topic names. Uh, Design pattern. So what exactly strategy design pattern is about? This normally, like anyone who starts with a basics like singleton or factory or some, but in general, if he gains an understanding that you have hold of Java and you are pretty well on it, right? So he might expect a better mm, uh, design pattern to ask, like the which are not normally asked, right? So that's what the benefit if it is this particular question is being asked up. So overall, what strategy design pattern is allow is going to it is allow you to define a family of algorithm. Basically, it is going to encapsulate each one and then make them interchangeable. Okay, so if it is useful when you want to switch between different strategies. Okay, so and you doesn't want to modify the classes that going to use them. So on a certain strategy basis, you can decide and follow that particular strategy and execute that basically. Okay, so now if you see that there is an at the root level we have an interface, and then we have the class is going to implement it, right? And then which has got pay method. Now under that, if you see, there is a context class which is going to make use of the strategy, that is an interface, and then it is going to execute that particular. So on based on certain strategy, under certain condition it is met, it is going to execute for a certain. So you can have n number of strategies defined for which can execute on that particular certain implementation. Okay, what is decorator design pattern? So it is going to uh, I mean, this particular design pattern is going to allow you to add a behavior to an object which is going to be dynamic, and then it is not going to affect your other objects of the same class as well. So that is the benefit of using it. And so when you are trying to, I mean, it is very useful when you're trying to extend the functionality, and in terms of like flexibility and using in the reusable manner basically. Okay, so here if you see the code, right, so you have a coffee and then you have a simple coffee, you have that particular thing, and then you have a milk decorator. So what you're doing here is that you're going to decorate your milk along with that, your coffee along with that, right? So and then you have to add up some cost over here, right? So you're going to add up some cost which is already there, and top of that you're going to add up some plus two, right? So some modification has been done, and so you're going to add it. So that's what you're going to talk uh, decorate that, and you can uh, allow you to add certain behavior of that object or in your own implementation. Now, in terms of AWS, if you are aware of it, we can make use of this. So the very first thing it was asked is that what is AWS IMS and what it helps in managing the access and security. Now, this is if you are not aware, like it's an identity and an access management in the services, which is there in the AWS, which is going to help you manage your user accesses, their permission in the AWS services, what kind of services they can access, what kind of user I mean accesses he will be having and permissions, right? So you're going to define certain policies, you have to grant some specific action to the particular policies, and then certain resources will be available based on this particular grants and the policies. So you are trying to make your application services secure, and it will ensure that securing your services are not everybody is able to access it. There are certain roles and the policies which are allowed to do that. SNS. So this is one of the simple notification services. So this is going to be in the pub subscriber model. So I would say so it is going to decouple the microservices, right? So it is one of the public subscriber model. If you have heard of Kafka or RabbitMQ, it is similar to that, but in the cloud, that is Amazon SNS. It has got their own services. Now this is going to decouple your microservices by allowing one service is going to push some messages to that particular topic. Okay, other than that services which is going to subscribe to and promote some loose coupling. So it is going to promote that loose coupling where you are not tightly coupled to something and then stuck with it. So you can easily subscribe to the topic and then you can send the messages. So SNS is used for that. Now, what is the difference between SQL and the NoSQL? So these are quite when you're dealing with database, like the traditional thing which has got table and the columns related relationship. We use the relational database, and it is quite of structured language. Okay, and we use SQL for it. And then if you wanted to perform certain operations, like you want to add some table, you want to do so, then we can use some manipulation, like you want to drop something data, update something, right? You have some certain predefined schemas also available, and so you can allow that, doing that with the SQL. Now when you're dealing with databases which are not traditional, which is not in the table and the column relationship, which is kind of schema less structures, which is like either document based or table I mean some other based, right? So storage dependency depends on that. So graphical way or like something, so we can make use of it, key value pair or something like that. So in that case we can make use of NoSQL databases, and it is purely non-relational, and the database names are like MongoDB. So it is a document based, Cassandra, right? So these are all databases which are not SQL or NoSQL basically. Now, what is CAP theorem basically, and how do you apply it to the NoSQL? So basically, when you're dealing with cap, it is the three things are that consistency, availability, and partition tolerance. So all, when it comes to consistency, it is going to ensure that all node return the same data, right? So whether you are calling uh, any nodes and you're trying to retrieve the data, right, it has to return the same data. Availability, so every request which is going to receive a request to that particular database, it is going to respond, right, at any cost, right? Your services not will be down, so it is will be available throughout. Now partition tolerance, this cannot, I mean, the system can continue to operate despite some network partitions, right? So there are some partition, in spite of that it is going to serve its purpose. Okay, so in terms of the NoSQL database, typically there is a balance between consistency and the availability. Sometimes we have to sacrifice one of them, right? That's the, you cannot achieve all this particular three, right? So either one of them has to be taken care. Now, how do you implement one-to-many relationship in SQL and NoSQL? Now, in terms of SQL, it's quite simple. We have the foreign key relationship, what we can define it. But when it comes to NoSQL, right, we can make use of the uh, concept of, referring the embeddable dependencies depending on the data type, right? So it is a document based, like it will be storing in the MongoDB like an embedded document. Okay, that's how we can actually define the relationship. Okay, so as I mentioned, in SQL it was quite easy, where we can mention the foreign key relationship and then we have that. But in NoSQL we have to, so you use certain references, or either you have some embeddable dependencies you can define on the database type, like a JSON. Under that, you will have certain JSONs, right? That's how defined. Now, what is sharding? This is quite important topic when it comes to distributing the data, which is distributed across multiple services, right? So when you're dealing with NoSQL databases, you have to scale your database, which is horizontally. So you have to break your large set of database into a smaller and a much more manageable pieces, so that it will help you to retrieve the data in a better way and a better performance. Okay, that's how the data is distributed across multiple servers for enhancing the performance. Okay, so it's called sharding. Now, what is the difference between union and the union all? Now, this is quite important questions, and I would say many of them doesn't reply to it. So when it in general, union, right? So it is going to return the distinct values, right? So it is going to remove all the duplicates. But when you have a union all, it is going to return all the values. It is whether it is duplicate or it is generally faster, because it is not going to double check the duplicates thing. So it is fast, but it has got duplicates, right? That's the difference. Now Docker, this is the containerization thing, and like it is how it is different from the traditional virtual. Now if you have heard of virtual boxes, right, where you have this particular virtual VMs where you deploy your applications, right? But in modern terms, in modern ways, we have the Docker, which is your Dockerization, containerization platform, which will going to package your application, their dependencies in the single container, and what the environment is required to run that particular libraries and things. So it is going to make available in that particular environment, and then it is going to run it, right? And it is also going to solve that issue where many developers say that it is running in my application on my machine, right? So different environment is going to run in all the different environment is going to run the same Docker, right? So it is be completely consistent across it. Okay, so that is at the Docker. Now, what is the difference between Docker run and the Docker exe? Now, when it comes to Docker run, this is going to ultimately create a new container, and it is going to start it, and then you can run the commands like the Docker. I mean, this is going to which is defined in the Docker file. Now, Docker execute is going to run the commands in the already running container. So as Docker execute is being run when the Docker is already been running up, right? So in the running container itself, you can execute certain commands. Now, what is Docker image and how do you optimize? Now, basically, There is a Docker image which is called, like, it is quite lightweight, standalone, and executable package that can contains everything what an software has to be needed to run it. Okay, so the environment, the libraries, etc., everything is there inside that to run it. Now, how do you optimize it? It is going to minimize some your uses of the base image, right? You have to minimize the number of layers it is having. You have to clean up unnecessary files which is there in the Docker file, right? So you have to check those and then you have to run it. Now this is an important, because Docker security is quite important. Okay, so containers and the images has to be secured. So what you have to do is that the official images which are kept, them, I mean, you have to always keep updated them, whether your images, whether or the containers, right? So you have to keep them updated, the images. Now you're running the container as a non-root user, that will make it secure. You can scan some images for the vulnerables, like Docker bench or Claire. We have some tools we can make use of, so you can scan those images. Now we have to certainly limit certain privileges and use certain securing options, like cap, drop, or read only, which is kind of secure, and which is secure, I would say. And we can use it to secure our Docker and the images. I hope this video was helpful to you, and also in terms of understanding how, what kind of questions have been asked up, and how you can prepare it for the next interview. If you happen to gain some knowledge, and also any needy people are wanted this particular kind of material, please do share with the needy people. Also, don't forget to like, subscribe, and hit the bell icon.